Hello everyone, welcome to another video. Today we are going to solve another problem on Mohr cycle. Okay, so let's get started. Okay, so here we have the equation that an element in a strained body is subjected to a tensile stress of 150 megapascal and a shear stress of 50 megapascal, tending to rotate at the element in an anti-clockwise. Okay, so anti-clockwise, that means negative. Okay, so anti-clockwise direction. You have to find the uh, two questions. Okay, solution for two questions. The magnitude of the normal and shear stresses on a section inclined at 40 degree, that means we have a theta that is 40 degree with the tensile stress. Okay, and the magnitude and direction of maximum shear stress that can exist on the element. Okay, so for our clear understanding, I will actually draw the object. Okay, so let's assume that this is the object, or this is our object. Let me actually take it over here. Okay, so let's assume that this is our object. Okay, so on this object we actually have 150 megapascal, which is tensile stress. So the tensile stress will be 150. So let this be 150 megapascal. Okay, and the shear stress. Okay, so the shear stress is 50 megapascal, and which is actually anti-clockwise, or which is actually tending to rotate the element in an anti-clockwise direction. Okay, so I have told you that in this case the anti-clockwise direction will be, okay, so the anti-clockwise direction will be on this plane. Okay, so on this plane and this plane. Okay, so the anti-clockwise direction, so anti-clockwise will be this direction. So the anti-clockwise direction, this is the anti-clockwise direction. Okay, so and now for making the element in equilibrium or stay in equilibrium, what we have to do, we have to complete the shear stresses, or the opposite reacting shear stresses that will occur in this and this plane. So that will be this, or clockwise, so clockwise this one. Okay, okay, so we have got the diagram, or we have got the elemental diagram for the question or the problem. Now we have to we have also been told that it will be 40 degree, right? Okay, so let's assume that this is our 40 degree. Okay, so this is our 40 degree, which is inclined with the principal stress or tensile stress. Okay, okay, so here we have got the picture. Okay, now we have to actually plot the question in the diagram. Okay, or we have to plot the circle in the graph paper. Okay, okay, so this is our x and y coordinate. So according to the coordinate system, this is our principal stress and this is our tensile stress. Okay, positive, negative, positive, negative. Okay, now what we have to do, we have to actually determine the 2 points, J point and K point. Okay, so J and K both are the points that we actually use to determine the points. Okay, so J and K, so the J and K points. Okay, so the J point is actually basically the points on the x-axis. So as okay, so first we will the x and y. Okay, so first we will like denote the x and then we will denote the y. So for the x-axis, what we will get, in the x-axis we get the tensile, so tensile stress is positive, right? So we will get positive, not 150, it will be 150 divided by 2. Okay, so why divided by 2? Because the center point will be this point, so the axis will be the center point. So as the axis is going to be, or the 0 0 point is going to be a center point, so the uh, circle will be on this form like this. Okay, so it will form like this. So moving forward to this, so as 150 is given, so 150 by 2 will be 1 point in the j, and as per this another will be minus 150 divided by 2. Okay. Okay, now let's come to the point. Okay, so before writing this, okay, so no issues, I can write this. Okay, so now what we have to do, we have denoted the x coordinates, now we have denoted the y coordinate. Okay, so in the x axis what we can see that it is anti-clockwise, that means it will be negative of 50 as it is given in the question. So as this is negative 50, the next will be positive 50. Okay, so it's like that in this axis it will be positive 50, right? This is the positive, so the for the k it will be positive and for j it will be negative. It's not always that it will be negative for j, it can be positive if the question says that the shear stress is acting on clockwise. Okay, and then it will be positive. So it actually depends on the question. Okay, so we have to actually determine the j first, and then we can determine the k. So that's how we do it. So I want to actually clear out the issues or clear out the doubts, and I am actually taking some more time or giving more time on emphasizing this point to determine the j and k, because if you make a fault or if you make any mistakes in determining the j and k point, you will actually get a wrong Mohr cycle, and your Mohr cycle analysis will be get wronged. Okay, so I am actually repeating the whole process again. Okay, so after drawing this, after drawing the elemental diagram, we have to determine the j and k point. Actually, j and k point are the uh, axis points or the points that will be plotted on the diagram, or sorry, plotted on the graph paper. So based on that we will gonna determine, or we're gonna draw the circle or Mohr cycle. So it is very important. So in this case we have one principal stress which is tensile stress, and another one is shear stress. So when it is one principal stress and shear stress, we actually determine, or we actually take the center point or the 0 0 axis as center point. Okay, so as we get this 0 0 point as center point, that means that if we have to draw 2 points j and k, we have to actually divide the principal stress by 2. Okay, so for getting the radius, right? So otherwise if we take actually 150, then we would not be able to get any center point or get any actually center point or any uh, actually human, I mean we will not be able to determine it. Okay, so we will not be able to get any center point, also we will not be able to determine the principal stress or the other parameters. Okay, so we just take the 0 0 point as the center point, as this is the center point. Now we have to determine the j and k. Okay, so for determining j, what we have to do, we have to just see. So j is actually on the x-axis, okay, not in y-axis. So it is actually connected to the x-axis. So in the x-axis we have the tensile stress 150. Okay, so 150 will be positive because tensile stresses are positive. Okay, okay, so tensile stresses are positive, so we will determine it as positive. Okay, so as it is positive, we will gonna write positive 150 by 2, as we have to write this is actually our r or radius. Okay, now after that we have to determine the shear. So the shear is actually anti-clockwise. Okay, so this one, so anti-clockwise, so the anti-clockwise, as it is anti-clockwise, it will be negative 50. Okay, so in for determining the k, it will be actually vice versa, like it is 150 by 2 positive direction, it will be negative and it will be now in negative direction for the k, and as it is actually negative, so it will be in positive direction for k. Okay, so after doing that, we'll actually plot these two values over here. As in that j is actually plus 75 minus 50. So plus 75 and minus 50. Okay. Okay. So and for k it will be minus 75 and plus 50. Okay, so here we get, so after getting this point we will actually uh, do this. Okay, so after actually getting these 2 points, we will actually join this and this point, so it will be joined through this. Okay, I have made a mistake. Okay, so let's use this. So we will actually made this with this. Okay. It will be nearly like this. Okay, so as I am actually drawing it with my free hand, so it may actually seem like this. Okay, so as we got this, so this point is actually our j point and this point is actually our k point. Okay, so now what we have to do, we have to actually right now we have to actually uh, draw the circle. So we have to draw the circle from the center. So from the center, okay, and to actually fix it up, so the radius will be now changed. Okay, so the radius will be actually equal to the these 2 points. Okay. Okay, so it will actually touch the point. So you will actually put your compass over here, and by taking the radius, this one will be your radius, this one will be your radius. Okay, so by taking the radius you will actually draw the circle, and that will also actually intersect this point. As I have drawn it barehanded, it will not intersect very clearly. Okay, so if you actually do it on the graph paper, you will see that it just matches. Okay. Okay, so after doing that, what we have to do, we have to actually then draw the theta. So I have told you in the first class that the theta we have been given in the question will be multiplied by 2, and it will be plotted over here. Okay, so always remember that you have to plot the theta or 2 theta. Okay, you have to plot the 2 theta with the k. Okay, so we have k, right? So we have the k point, so and we have the okay. Okay, so okay point. So for the okay ray, we will gonna plot, or we will gonna draw the 2 theta over this in a clockwise manner. So it will be 80 degree, so seems like it will be 80, and after that we will gonna just do this. Okay, so as it is 80, it will be like this. Okay, so after drawing this 80 degree from the OK over on the OK axis or on the OK plane, we're gonna get this ray. Okay, now what we have to do, now we have to just draw a straight line from that. That's it, we have completed our drawing. So what we have to determine now, we have to determine the things that are required. Okay, so the magnitude of the normal and shear stresses. Okay. Okay, so what will be the normal stress? The normal stress will be this portion. This portion will be the normal stress. Okay, for the a 40-degree inclination. Okay, so this will be the normal stress. Okay, and for the shear stress will be, okay, so the shear stress will be this portion. This portion will be the shear stress. Okay, so that's it. If you want to determine the shear stress, then you have to just determine this portion. Okay, and for the normal stress, you have to determine this portion. Okay, so in the graphical method, you actually put one small box equal to a unit, say like 5 unit. Okay, 5 unit, and you have to actually make it very clear and remind yourself like that you have to take 5 units. Every small box equals to 5 unit for each the axis. For x-axis and y-axis you have to take this small box equals to 5 unit. You can take it as 10, but always remember to take the same unit for the both axes. Okay. Okay, so after that we have actually determined this one. Now what we have to determine the magnitude and direction of maximum shear stress that can exist on the element. Okay, so maximum shear stress. Okay, so to determine the maximum shear stress, we actually have, this is the maximum shear stress. Okay, and this one is also the maximum shear stress. Okay, so the maximum shear stress will be plus minus T max. Okay, it will be equal to the radius. Okay, so it will be equal to the radius of the circle. Okay, because this is the toppest point and this is the bottomest point. So toppest point on the y-axis, that will be the positive r, and on the bottomest point it will be negative r. So to determine the r, how can we determine the r, right? So to determine the r, you can actually apply Pythagoras theorem on this triangle, and you can actually determine the t maximum. Okay, so this way you can determine the values. Okay, and this is the solution. If you want to actually check if you are right or wrong, or if your calculation is wrong or right, you can actually check this way. Actually, as this is a graphical method, it will be plus minus to these values, it will be close to these values, and if it is under 0.5%, or if it's under 0 to 5% error, then it's okay. It is actually considerable range. So thank you for listening, and thank you for the problem solving so with me. Now just practice it, and don't forget to practice it on the graph paper. Thank you.